All right, I'm going to show you two ways to do this problem. The first way, since we've got division involved here, is I'm going to understand, because of this subtraction sign right here, and this would work the same way with addition as well, I'm going to understand that this 4xy to the second in the denominator, I have to divide into both of these terms up here. So if I rewrite that, I've got 8x to the second, y to the third, over 4xy to the second, minus 28 x to the third, y to the second, over 4xy to the second. So dividing out each of these fractions we set up. 8 divided by 4, 2. X to the second over x to the first. Subtract those exponents, get x to the first. Y to the third over y to the second. Again, subtract the exponents because of the common bases. Got y to the first. Minus 28 divided by 4, 7. Got x to the third over x to the first. Subtract exponents, get x to the second. Got y to the second divided by y to the second. Cancels out, right? It's y to the 0, it's 1. So there's my answer. That's one way to do this. Now, a second way to look at this is to consider some factoring. So if I take this top binomial expression and I find, say, a greatest common factor. Greatest common factor between 8 and 28. What is it? What goes into both? 4. All right, so I could take a 4 out. As far as the x's are concerned, I've got an x to the second here, I've got an x to the third, so I've got to take the smaller power between those two, x to the second. I've got a y to the third, I've got a y to the second, so y's are present in both terms. Take a y to the second out because that's the smaller power. If I look at what remains when I factor out the greatest common factor from the numerator here, well, I took 4 out of 8, so 2's left. Took 2 x's out, there were 2. Took 2 y's out, there were 3, so there's 1 y left there. Minus, all right, 4 goes back into 28 7 times. Took 2 x's out, there were 3 there, so 1 x left. Took 2 y's out, there are 2 y's there, so no y's left. There's my factorization of the numerator. That's all over 4xy to the second. Now, because these are multiplied pieces on top, I can take what is a monomial expression right here, and I could divide into that GCF right there. If I divide in the 4's, well, they divide out, right? As far as the x's are concerned, you got x to the first here, you got x to the second there, so that one's going away. There's 1 left there. And the y to the second and the y to the second, well, they divide out. So what remains is x to the first times the quantity 2y minus 7x. Now, is that what I got up here? Well, basically, yeah. If you multiply it out, that's what you got up there. But there's a second way to do it. Now, considering the technique we just used on the last problem. On the last problem, we tried it 2 ways. We were dividing by a monomial expression on the last one, which made it convenient to take whatever was in the denominator and divide it to every term in the numerator. Here I don't have a monomial expression, I've got a binomial expression, so that doesn't make sense to do. The factoring technique, though, that worked on the last one, maybe we could put that in play here. You know, maybe that numerator is factorable. If you try factoring the numerator, break up this quadratic. Well, let's think about this for a minute. The 3b minus 2 on the bottom is going to be unchanged. And for this to work out nicely, it'd be really convenient to have a 3b minus 2 up here, right? Because then a 3b minus 2 might divide itself out. So thinking about these first terms, multiplying to get 9b squared. I could throw a 3b in there for each of the lead positions, right? I'm kind of keeping this 2 down here in the back of my mind for guidance. Trying to multiply to get 10 up here for these last terms, maybe put 2 and 5 in. Can we create something here that works as a factorization? Looks like we could, right? Outside term, make that a positive 15b. Inside, if you FOIL this back out, that'd be a negative 6b, and if you put that together, that gives you this 9b back. So it turns out it does factor. And since it does factor, and we've got multiplied pieces up here, and the 3b minus 2 matches the 3b minus 2 down here, these guys divide out, and your answer is 3b plus 5. So we see how using factoring could be a possible technique for us for division. But what about long division? Let me try long division on this same problem. Let me take this 9b to the second plus 9b minus 10. Let's take that and divide by the 3b minus 2 this way. We already know what the answer is supposed to be. Let's see if we can get there the same way, or a different way, rather. All right, using long division when we're playing with polynomials. Start with your lead term here of 9b to the second. Compare that to the lead term out here, 3b. Take 9b to the second, divide by 3b. What do you get? You get 3b, don't you? All right. So I'm going to put 3b up here because 9b to the second divided by 3b is 3b. And if these were real numbers, I'd be taking whatever I have right here, multiplying to the 3b minus 2. That gives me the stuff that goes down here I got to subtract, right? So 3b times 3b minus 2. Distribute that out. You get 9b to the second minus 6b. So I'm supposed to be subtracting that. If I'm subtracting that, got to change these signs, distribute a negative 1 through. These lead terms cancel out. You've got 9b plus 6b. You've got 15b. And then the next thing we do with long division is we carry down that next value, in this case next term, carry down to minus 10. All right, we start this game over again. Okay, now we're taking this 15b right here. I'm dividing by this 3b right here. When I do that division, I get 5, right? And it's positive 5. So I'm going to add that 5 up here. Whatever goes up here, we multiply back to the 3b minus 2. That result goes down here, and then we subtract. So 5 times 3b, 15b. 5 times negative 2, negative 10. And we can see how if we subtract this all out, changing these signs, everything goes away and the remainder is 0. So what's our answer? Our answer is 3b plus 5. All right, if I got to divide this one, you know, factoring is always in the back of my mind to help me out here. But the only factoring I could really use, since this has got 4 terms right here, is factoring by grouping. And it looks like if you try factoring by grouping, it's not going to get you too far. So we saw how long division does work. It is a technique we can use, so let's try long division again here. Let's set up the 4x cubed minus 8x squared plus 3x minus 8. Let's divide that by the 2x minus 1. So just like we did before, we'll start with the lead term here, 4x cubed, compared to the lead term out here, 2x. Divide that out. 4x cubed divided by 2x is going to be 2x squared, right? So 2x squared, going to put that right there because it's above the x squared term. That's why I'm putting it right there. I'm going to take 2x squared, multiply the 2x minus 1. So distribute that out. 2x squared times 2x we know is 4x cubed, minus, since we're multiplying by 1, 2x squared. We subtract this, changing our signs. 4x cubes go bye-bye. We've got negative 8 plus 2, negative 6, x squared. Bring down the next term. Start the process over again. Lead term now is negative 6x squared. Divide that by the 2x, lead term out there. So negative 6 divided by 2, we get negative 3. Got x squared divided by x, x. So negative 3x is what we're going to distribute to 2x minus 1 here. When we distribute that through, we get negative 6x squared. Since it's a negative 1, it'll be plus 3x. Okay, this one's kind of interesting because now, if you subtract it out, you're changing these signs here as you subtract it out. Not only do those lead terms, those x squared terms cancel out, but the x's cancel out as well. Meaning we've got nothing here. But we still got to bring down one more term. So we bring down the negative 8. Now, 0 minus 8 is negative 8, right? So really I don't need that there anymore. If we continue with the same process, you'd be taking negative 8, dividing by 2x, but that doesn't work, does it? So what's negative 8 represent? You know? Is that our remainder? Yeah, negative 8 is going to be our remainder. So our answer when we divide by 2x minus 1 to this polynomial is going to be 2x squared minus 3x, because that's everything up here. But then we do have a remainder, so we're not going to write our negative 8 like we're in 5th grade here. We're going to write minus 8 over 2x minus 1 because that's what we're dividing by. It's kind of like a mixed number version for an algebraic expression here. This is our answer. All right, so long division one more time. We're going to take 2x cubed, and notice the way this is written. You've got these polynomials that are always written where you've got your highest power of x first, next highest power of x next, and so on down the line, right, until you get to the constant. There's no x squared term here. So we need to make sure we include that. To include that, I'm going to put a 0 in there in the place of that x squared term. So you've got the 0 x squared minus 2x minus 3. Now every power is accounted for in descending order. That's one way to look at it. We're taking that, we're dividing by x minus 1 using long division because the 2x cubed minus 2x minus 3 we start with, it's not something we can factor out. All right, here we go again. Start with the lead term here, divide by the lead term there. 2x cubed divided by x is going to be 2x squared. 2x squared goes right here. I take 2x squared, I distribute to x minus 1, get 2x cubed minus 2x squared. We subtract. Changing these signs. 2x cubes are gone. 2x squared's left here. Bring down the negative 2x. Start the process over. Lead term now is 2x squared. 2x squared divided by x there is going to be 2x, and it's positive, so I'll say plus 2x up here. Take 2x, distribute to x minus 1, get 2x squared minus 2x. Similar thing happens on this problem as it did with the last one. You adjust these signs, everything is going away, you got 0 again. And if we're bringing down this -3, understanding that 0 minus 3 is just -3, trying to divide -3 to x minus 1 is not going to work. So -3 is that remainder, meaning our answer is 2x squared plus 2x. Since it's -3, we say minus 3 over x minus 1. All right, so way number 3 here out of all these division methods we could use is synthetic. To do synthetic division, you start with a little box here. Kind of an unfinished look. You start with a little box. Inside that box, you take what you're dividing by here. Since it's x minus 4, put a value in that box that makes that divisor 0. So, long story short, just change the sign, right? Change the sign on that -4 to +4. Put 4 in the box. Okay, next to this box, we're going to spell out a row of numbers. That row of numbers is going to consist of all the coefficients from the polynomial we're dividing into. So coefficients would be 2, -7, -8, and 16. And it's important to note here that all these coefficients, you got to make sure every term is represented. Kind of like on that last problem, we didn't have that x squared term, so we had to throw a 0 in there. Had that been the case on this one, I'd have to throw a 0 in somewhere. But everything's going down in order, starting with 3, so we're good to go. All right, now I'm going to skip a row. I'm going to draw a line, like a big old equal sign. At the end of this line, corresponding to this column right here, I'm going to draw another box. I'll explain what that box is when we're done. But here's how synthetic division works. We start by taking this first coefficient of 2 and bringing it down. It goes underneath the line. Take that 2, multiply back to the number in the box, so get 8, right? That 8 goes in the next column. Now, add through -7 and 8. Get +1. Take 1 now, multiply back to the number in the box, get 4. That number goes in the next column. Add through this column, -8 and 4. Get -4. One more time, take this number we just got, multiply back to the number in the box, -4 times 4, -16. That goes in the next column. Add through, get 0. Now, we started with a polynomial that we were dividing into. It was a degree 3 polynomial. Right, that was the highest power there, power 3. We were dividing by something linear, so highest power is 1. Meaning our end result here should be some kind of quadratic, right? We should have gone down a power from where we started. These values right here represent the coefficients on our quotient. This 2 is the coefficient on x squared. I'm just going down by 1 from here to get that x squared. This 1, which is positive, is the coefficient on the next term down, which would be x to the first. Meaning the only thing left would be this -4, which must be the constant. Now what the 0 represents, the 0 is our remainder. So what this means is when we take the polynomial we start with and we divide by x minus 4, there's no remainder left. It just means that x minus 4 went in there evenly. And a quadratic is our answer.